The SBC has issued a day 2 slight risk for regions in Illinois and Indiana. This is going to include Chicago and a broad portion of Illinois, as well as a good portion of Indiana, including parts of Indianapolis, Valparaiso, Terre Haute, and many cities on the border here. This has an accompanied 2% marginal tornado risk, as well as a wind at 15% and hail at 15%. So we're going to be looking at this setup because it does have some significance, and I would like to talk about this because I have my eye on this, and I think this could be an underrated setup and have some important, some important severe weather that goes on with it. So we're going to be looking at synoptics and what will be going on this day. First thing I want to look at, though, is our trough progression. So you can see here's 15Z. I'm looking at the 15Z wrap right now, and this will get us throughout our forecast period. We have a broad troughing out here on the west coast. Here's the Rockies. That's Utah right here. And we have this broad troughing. This will be moving on to the east as time goes on here, right? And you'll see that this strengthens pretty significantly. It's also a very cold 500 millibar low. If we see here, it's a very cold core. There's definitely colder air on the backside of it, but in the center of the low here, we do have temperatures that could reach, pretty cold. RAP has -25. The NAM has a little bit warmer. I think the RAP is a little bit extreme, but -22 is pretty widespread. If we look at our high-res ensemble forecast as well, you'll see a very similar story. Here's our 500 millibar level again, and let's zoom in here to the Midwest sector. We get our temperatures here for this time frame as well. We have a -22 contour here, so pretty cold air aloft is being forecast for this low. And that means we're gonna have a pretty solid cold core setup. I'm also been looking at Davies et al. 2006 a little bit here. In particular, this analog that they have is very similar to our current setup. So anyway, let's look at our surface features and everything. Here's 500 millibars again. Pretty strong flow. 18Z again, pretty strong low. We talked about it's cold aloft. 850 millibars again, same thing. Pretty good flow. The majority of it's on the backside of this. Good moisture as well. Definitely lacking moisture in some respect, but moisture is somewhat at play here. And at the surface is where things also get interesting. Let's look back at the wrap again, and you'll see we'll have some model differences that I want you guys to really pay attention to. So broad scale, we have a very intense cyclone with snowfall very likely on the backside of it. A very warm air in Illinois. You can see 70s overspreading the region, as well as mid 60s here as well. Moisture is lacking. That is something to note. Moisture is quite lacking in this setup. In our wrap model, we do have a good amount, a little plume of moisture up here near our warm front, but our NAM model shows a much, a lot different of a picture here. The wrap has a much quicker moving cold front compared to the NAM, less moisture on the NAM, likely due to the fact that it's not being pushed together as much. I'm looking at mixed dew point here as well. You can see how much moisture we have from the lowest 30 millibars of the atmosphere. The wrap run shows again a lot more moisture in here, so it's something to pay attention to. Let's look at the wrap for now though, and I think the wrap might be showing a good uptrend as to what we might be seeing, especially if you look back at last frame. So you can see here's our surface low out here, and you'll see this is instability, surface base cape here. 18Z, that's 1 p.m. Central Time. We have instability basically over a broad portion of Illinois. Not incredibly intense, but in some regions here we're hitting 500s. Here's even close to 1,000. The blue is 1,000. You'll see right there at about 3 p.m. you get this pretty big plume of instability, pretty intense for the season at least, instability up here compared to everywhere else. And this actually becomes pretty broad as the time period goes on here, all the way to 9 p.m. Central Daylight Time. But in particular, this bullseye is interesting. So looking at our Davies et al., this is a cold core setup. So we talked about our low here, right here. We have this, we have this cold air aloft. You would place the low probably centered somewhere around central Iowa. We can place that right over central Iowa. We look at the surface. That was 18Z. So let's go back to 18Z on the wrap run here. Our surface low a little bit off to the, it's if we remember that our upper level low is going to be right about here, our surface low is pretty close to it. I would probably place it, it's a little bit tough to tell on this one actually, just because of the, it's a weird frontal kind of system. I put a warm front here, probably put a cold front about here. I mean, this is a good spot to put the low, but the upper level low and our surface low are pretty close in proximity. somewhere, I believe this is about 100 miles right there, which is very similar to what we see in this Davies et al. Less than 200 statute miles, we are in that portion. We have this warm front with an occlusion incoming as well. If you look at our NAM, this is much more apparent, right? Or at least the wrap here. Let's move forward to 21Z and you can really see what I'm talking about. This low has an occlusion, which doesn't look like a cold front, but it's some kind of boundary here. Certainly some kind of boundary right there. You can see a very, somewhat of a secondary surface low out here, but I would say the surface low is, the main surface low is right here, the warm front up here, and an occluding cold front associated with that as well. You'll see if you look at our moisture, it's very similar right there as we done a little surface analysis there. 500 millibars, the closed low is out over here. So here's our, probably right about here. They're in very close proximity to each other, meaning, whoopsie, they're in very close proximity to each other, meaning that the thermodynamic profile, the colder temperatures aloft are really going to help this system. And this has been forecast in this wrap model. If we look at our instability, it's really blowing up here due to these steep mid-level lapse rates. Let's delete all my surface analysis. Even just click mid-level lapse rate, you can see right in that region near that warm frontal boundary and the occluded front, you have these pretty steep low-level mid-level lapse rates. Low-level lapse rates are also pretty impressive, especially in regions out in northeast Illinois. Here's our sounding that I just took, and you can see something very impressive here. 3 cape is sitting at 208 joules per kilogram, so pretty intense. Really fat cape there as well. So these storms would be able to fire off. There's definitely something to be wished for in the moisture, but we do remain pretty saturated throughout much of the profile here. We have that curvature in the lower levels, and if these storms are surface-based and taking advantage of the lowest levels of the atmosphere, we're certainly where we want to be. Our EL is right about 9 kilometers. I'd say 8.8 kilometers is probably about right. If you look at our analogs from Davies et al. 2006, let's see, elevated, yeah, here it is. Equilibrium level is at, yeah, right about 8,000 to 9,000 meters above the surface, which is much different than typical supercells. But in our case, in this cold core setup, we definitely have this. Surface-based cape in our wrap run here means at 2,000, so it's definitely an upper echelon event for cold core setups. But even the NAM run has been showing less cape. We are kind of in our region, a little bit on the lower end, I will admit. I think the NAM is going a little bit too low on their 500 millibar temperatures, and the wrap is going way too, other way around. NAM is going too high in the 500 millibar temperatures, and the wrap is going way too low. I would guess somewhere around negative 23 degrees Celsius, but every little degree counts, and even in this sector here, you can see the NAM has negative 19. We compare it to the wrap, it has, negative 25 here. So I think a broad negative 23 degrees Celsius up here would be possible. Here's our NAM sounding, but again, you have about 800 joules per kilogram of cape. And we look at surface-based cape, and you can see our lower level, so this is 25 percentile right here for cold core setups. We have 765 is the lower end. So we are well within the 75th to 25th percentile. Probably about 30 or about maybe 35, but we are within that range that we want to see. Bulk shear, let's look back at our sounding. 0 to 6, 24 knots. Yeah, which is also within that region. So the NAM is showing that we're within this region. The wrap is showing the upper echelon. But in either way, if we kind of average out the wrap and the NAM, we're going to be right on par with this setup as we're thinking. SRH values are actually much, much higher. 150 almost, 0 to 1. The wrap sounding has about 120. So we'll say even 120 here is upper echelon in both cases. Yeah, let's see. 0 to 1 shear. I'm just comparing some of these here. 0 to 1 shear on the NAM is 26 knots. The wrap has 18 knots, which again, in both cases, right in that vicinity. So based on our analog data here as well from this paper, this is very much a cold core setup. Your most likely area for tornadoes is going to be around that warm front, right? So we have a little bit of a stagnant warm front sitting here right about the Illinois-Wisconsin border throughout the day. So I would definitely be forecasting to see the highest likelihood of tornadoes right in here if we're looking at the wrap run especially. The moisture is maximized there. And another thing is going to be vorticity in 3 cape. 3 cape, it's a really important metric. Looking at this, 3 cape is much higher in these cold core setups than they are in the supercell setups. And you'll see that our 3 cape, let's click on that. The greens indicate over 100. The yellows are over 200. A very widespread region of 3 cape, even up here as well. So this could be a very, very good day for severe weather especially. And if the moisture on the wrap does come to fruition, we're going to see a lot more robust instability and really just a more intense setup here. One thing I wanted to do is actually look at another day. This was last year, February 27th, and comparing the two, we see that our surface low on February 27th is much more to the north. By the way, the February 27th event, that was an enhanced risk somewhere right about here, where we saw a 10% hatch tornado risk come to fruition, honestly. Pretty intense as well. This is on mute, but you'll see this play out. Look at our surface vorticity and 3 cape. You can see we have that warm front. We have that kind of trailing occlusion slash. It's kind of a strange boundary here, but you have that sector where you have that warm air and good moisture. We have a very, very similar story for us here. If you look at vorticity, you have this boundary to your south, right? And the one issue is that we don't have nearly as large of an open kind of warm sector thing here. The warm sector is lacking. It's a very small, narrow corridor, but the potency is definitely right in there. And you can see it. You can see this pretty well defined on the 3 cape vorticity combination, because that's really what fuels your storms. You get any vorticity at the surface. You can see we have a lot of vorticity on these boundaries, and the 3 cape is able to stretch that vertically, and that can help you with any tornado genesis. And watch as this progresses as well. You get a really intense couplet or bullseye of 3 cape. If we look at our case here, same thing. The wrap gives a really intense bullseye. How much is that? 250. Oh wow, nearing 300 joules per kilogram of 3 cape. So very intense low level instability. I want to take a sounding here because I'm honestly really curious how that might play out if that were to occur. That's a very intense look. Again, it's very similar, I think, to this sounding here. You can see how higher instability is in those lower levels. These storms become surface-based immediately. This is only 500 meters above the ground, very close to the surface. We have lots of curvature in our photographs as well. So this could potentially be something more significant to pay attention to. The SPC did mention that if moisture is able to really get into this setup, we could see higher tornado probabilities be needed. I see this happening, frankly, as of now. Just looking at our trends. The NAM has uptrended, I believe, in moisture. Let's look at our past runs. Here's 21Z on the NAM at 12Z today. The 6Z NAM had a broader, but also drier warm sector. If we go back to the 16th, oh, not far enough. Let's go back to the 17th at 0Z. Yeah, less moisture. So we have been uptrending in moisture for sure. The wrap likely has a very similar story. Here was yesterday at the 15Z run. The moisture was definitely lacking. So you can see 50s dew points overspreading Illinois. And the wrap run uptrends pretty significantly to even high 50s, you could say, mid 50s along much of this region. I do believe that the wrap is over forecasting this a little bit. The dew points are too high, in my opinion, and the temperature aloft is way too extreme. I think it's showing too much instability, but considering the NAM is kind of the low end of the models as a whole, we are fitting right into the metrics that Davies et al. Put together for setups like this, especially considering we have, and this is really, really similar to what we have at the surface. So, it's a really good analog. We have a day very similar to this where we saw a pretty prolific tornado event in the Chicago Metroplex. So, we could have another severe weather event just like that. Let's look at our cam on the HRRR, kind of understand how this progresses. Here's 12Z, a little bit of morning convection, maybe even here. But here's our second line of storms behind this. You can see a lot of these are more discrete in nature. Also, we have this more possibly linear, but possibly discrete region out here in Indiana as well, and I'm paying attention to. Our tornado risk does go over a very broad region. If we look at our wrap run again, you can see we get this pretty, the dew point's the easiest way to tell this boundary. A pretty large boundary, looking at storm motion, pretty quick moving storms for sure. Slower storm motion more up north. Down here we have much faster storm motion vectors. The one thing though is that SIGTOR is much more impressive down here. Let's just look at this, just so we can see where our best environment is. I'll probably do the mid-level lapse rates as well, but frankly a lot of convergence along this boundary, lots of vorticity, and again 3 cape is the real driver of this setup. Very large area of intense 3 cape, even intensifying later on in the night here as well, possibly into northwest Indiana, southwest Michigan. After this, it becomes a little more uncertain, but the HRRR is also showing a very similar story here. Lots of instability, 3 cape. I mean, this is very impressive 3 cape. It's up to 300 in some portions on here. Here is our Sigtor, and not the best looking hodograph or CUT, I will admit. You can see we do have that pretty solid cape in there. 3 cape, also very intense. I don't really trust the Sigtor, in all seriousness. The intense significant tornado parameter, I think it's overdone. I don't trust we will see a extremely violent tornadoes, but this could uptrend until then. So I will be paying attention to this event in the future. If there's any updates, I will let you all know. Keep tabs on my community posts. That's usually where I update if I have a chance. But it could be a very prolific event, so definitely keep an eye out for this, especially if you're in the risk area. I think this is going to uptrend. I wouldn't be surprised to see a 5% contour somewhere in here. Maybe even just a general broadened 5%, because this could, if the wrap run comes to fruition, this could really be I wouldn't say, prolific, but it could be rather intense for March and a little bit unexpected as well. So do keep an eye out if you're in this risk area. I will be paying attention. But that's about it for this video. Again, if you like this sort of content, please let me know in the comments and leave any feedback you have on how to improve or things you like. So with that, thank you all for watching, and I will see you all next time.